This is section 2.2. We're going to be talking about circles. In this section, we're going to write an equation of a circle in standard form, and then we're going to write a general form of an equation of a circle. Our first objective is to put in the standard form an equation of a circle. So the standard form of a circle is x minus h squared plus y minus k squared is equal to r squared. The center of the circle is at hk and the radius is r. R, you will notice, is greater than 0. So we note when hk is at the origin at 0, 0, we just have x squared plus y squared is equal to r squared. If you can see by our diagram that r is a radius coming from the center of the circle to a point out along a line that goes around the circle. You can see that at each point in the circle that we have essentially the Pythagorean theorem for each point on the circle. Notice that there's a right angle made on the x-axis as we rotate the radius around this direction. So in this section we're going to graph a circle. We're going to put the circle where it is on the graph, and then we're going to actually draw the circle. So for the graph of a circle with the center at -2, 3, and a radius is 4, we will put the center of the circle at 2, 3. You notice at -3, we're here, and we're right here as far as the circle is concerned. And then we put the points where the radius will hit along an axis of the circle. And if we go 4 directions down and 4 directions up, we see that we have our circle at various 4 points. Then we can draw the circle. You can see in this particular chart we can draw a perfect circle through the points. So in example 2, we write an equation of the circle in standard form and graph the circle. The center is at 4, 3, and the radius is 3. So for h, the number is 4, so we put it into the standard form of the equation. And for y, the k portion, we put in 4, 3. Notice they're both negatives. So the reason why is when we put 4 into x, 4 minus 4 is equal to 0. So to get back to the origin, we just put in the positive part in each x, y. You'll notice the radius is the square in standard form, so we square the radius and we put it in standard form of 9. Now to graph the circle, we put the center at 4, 3, so we move over and we see that we have a red dot at 4, 3. And then the radius is at 3 points up, 3 points down from the center, and 3 points to the right, or 3 intervals to the right and 3 intervals to the left on with the x-axis. Now we just draw the circle, which is a little harder to do, and we're going to try to do it here. Doesn't have to be perfect, as long as we try our best. So these are the points that are along the line that go through the points. Here's our practice skill 1. It says write an equation of a circle with the center 3, minus 1 and a radius 4. Then graph the circle. So in standard form, here it is. It's x minus 3 squared plus y plus 1 is equal to 16. Notice a negative k, so 1 comes in to be a negative k, but a negative times a negative is positive, so it becomes a positive 1. Now we graph the circle, and that was my attempt to graph this circle. We found the center first, and then we counted the radius in the different directions. So in practice 2, we write the standard form of an equation of a circle with endpoints of diameter negative 3, 3, and negative 1, 1. Sometimes we want to put these points on a graph and see how they go, but we note that we need to use the midpoint formula here, because for the diameter, the midpoint is where the radius is going to be from the center. So we use the midpoint formula, which we learned in chapter 2.1, which is the x portion of the center is going to be at x1 plus x2 divided by 2, and the y portion of the center is going to be y1 plus y3 divided by 2. So we use this formula to find the center, and now we just plug in our information here. We have negative 3 plus a negative 1 divided by 2 for the x values, and for the y values we get 3 minus 1 divided by 2. So we get a negative 4 divided by 2 for x, and 2 divided by 2 for y, and so our center is at negative 2 comma 1. We plug this into our standard formula, and we get x plus 2 squared plus y minus 1 squared is equal to r squared. Now to find r, we plug one of the points in to the formula, and in this case we'll plug in negative 1, 1. That seems to be the easiest. So when we plug it in, we get a negative 1 plus 2 squared plus 1 minus 1 squared is equal to 1 plus a negative 2 squared, which is 1 plus 4 is equal to 5. So our formula becomes x plus 2 squared plus y minus 1 squared is equal to 5. So now the general form of a circle is just like in our cases of polynomials. We put everything equal to 0. We use the zero principle. So we move everything over. The radius and all terms are put over on the left-hand side equal to 0. Notice we've expanded out the standard form of a circle in this particular case. So for example, suppose I have x minus h squared plus y minus k squared is equal to r squared. To put it into the general form of a circle, we expand this. We get x squared minus 2h plus h squared plus y squared minus 2k y. Oh, we forgot an x here. Plus k squared is equal to r squared. And now we move all the terms over, so we get x squared, and we usually put this as y squared. We then put the terms minus 2hx minus 2ky plus h squared. These are now numbers, k squared minus r squared. is equal to 0. So there is our general form once we expanded out the standard form of the equation. So in example 4, we write the equation of a circle in general form, where we have x plus 8 squared plus y minus 1 squared is equal to 25. The first step is to expand our terms, which we have, which we now have x squared plus 8x plus 16 plus y squared minus 2y plus 1 is equal to 25. And we see that we're going to put the terms in order. So we have x squared plus y squared plus 8x minus y plus 17 is equal to 25. And now we bring the 25 over and add it to the numerical answers, and we get, or the numerical numbers, and we get x squared plus y squared plus 8x minus y minus 8 is equal to 0. So if we start out with a circle in standard form or general form, we need to write it into standard form. So to write an equation of a circle from general form into standard form, we must complete the square twice. To write the equation in standard form, then we can identify the center and the radius. So we start out with our equation, x squared plus y squared minus 4 minus 20y plus 68 is equal to 0. So the first step is to group the terms, the x terms together and the y terms together. So that's what we did here. We grouped the x squared minus 4x, and we grouped the y squared minus 20y, and then we had 68 is equal to 0. Then we moved the numerical answer over. The 68 now becomes a minus 68. We have the two similar terms, x squared minus 4x parentheses plus y squared minus 20y parentheses is equal to a negative 68. Now we'll go to the next page to finish this. So now we complete the squares. So we took half of 4 and we squared it and we got our 4. So now we have x squared minus 4x plus 4. We took half of the 20y and took half of 20 and we squared it and we got 100, and we added it. So now we have y squared minus 20y plus 100. But whenever we add 4 and 100 on one side, we have to add it on to the other side. Now we have the perfect squares, x minus 2 squared plus y minus 10 squared is equal to, when we add these all up, 36. So the center is at 2, 10, and the radius is at 6. Here's example 5. Write the equation of a circle in standard form. Identify the center and the radius. So again, we're going to group the x terms together. So x squared plus 10x parentheses, y squared plus 4y together, and I'm going to move the 21 over to the other side of the equation. Now I'm going to complete the square. So here I'm going to complete the square here. So I get x squared plus 10x plus 25 plus y squared plus 4y plus 4 is equal to a negative 21 plus, I had to add a 25 plus a 4. So now I get the following. I have a perfect square, x plus 5 squared plus y plus 2 squared is equal to 8. The center is at a negative 5. comma negative 2, and we have a radius, which is the square root of 8, to square root of 2. Practice skill 3, we write an equation of a circle in standard form, then identify the center and the radius. So we group our terms first. Here they are. We get x squared minus 8x plus y squared plus 2y minus 8 equals 0. We move the 8 over. And now we are going to complete the square. So we take x squared half of 8 and we square it. So we get x squared minus 8x plus 16 plus y squared plus 2y plus 1. We add the 16 and the 1 on the right hand side of the equation. So we end up with x minus 4 squared plus y minus 1 squared is equal to 25. And so our center is at 4 comma negative 1, and our radius is 5. So determining an equation represents the graph of a circle. The equation x minus h squared plus y minus k squared equals r squared represents a circle of a radius r only if r squared is greater than 0. If r squared equals to 0, then the equation is x minus h squared plus y minus k squared is equal to 0, represents a single point hk. So the solution set is just hk. If r squared is less than 0, then the solution set is an empty set. So in practice skill 4, we write the equation in the form x minus h squared plus y minus k squared is equal to r squared and identify the solution set. So again, we group the x's. We get x squared plus 2x, and now we just have a y squared is equal to a minus 5. And now we have x squared plus 2x plus 1 plus y squared is equal to a negative 5 plus 1. So now we have x plus 1 squared plus y squared equals a negative 4. It's less than 0, so we have no solution here. When we graph the circle on our calculators, on our TI-83 or 84, a basic graphing calculator usually requires the equation in the form y is equal to k plus or minus the square root of r squared minus x minus h squared. So when we given this equation, we identify our different components. Here's our r squared. Here is our h. Here is our k. And so in this particular case, we have a positive k here, which is 3. And then we have our r, which is here. And then we have our x minus h, which is here. And then taking the square root. And we have two equations. We have a positive equation and we have the negative equation. Now we're going to put those two equations into our calculator. So on your calculator you have a y equal key, and when you do you'll get y1, y2, y3, y4, y5, and so forth. So you will move your arrow key where it says y1 and you'll type in 3 plus the square root symbol, parentheses comes up, and you'll put a 16 minus, and you'll hit a parentheses x minus 2 parentheses closed, and hit enter. And then on the second line, where it's y equal 2, you'll put in 3 minus the square root symbol, and do the same thing, 16 minus x plus 2 parentheses closed. And then you'll hit the graph key. When you hit the graph key, you will get this particular graph, it looks a little distorted, but it turns out that on the next page, which we're going to next, that if you want to eliminate the distortion, you go to the zoom menu on the zoom key and you select z squared. So there it is. If you go to the Windows key, that is what it looks like there. You can always adjust the size of your circle by either increasing it or decreasing it by going to the Windows key and changing the scales on your calculator. Well, that concludes our chapter on circles. The reason we learn circles is that a lot of particles move in circular motion, not only at atomic scales, but also some objects in our atmosphere and certainly in our world and solar system move in some sort of circular pattern. Sometimes it's elliptical, and we won't talk about that in this class, but certainly in future classes.